Hello everyone, welcome back to our discussion on automated testing in Android. So last time we saw how to set up testing environment in your Android Studio and also the basics of test-driven development, that is TDD. Now we'll continue with developing an app through test-driven development. If you remember, we are talking about the Units app, which lets the user convert quantities from, say, Celsius to Fahrenheit, etc. Okay, so let's see the class diagram or the architecture of the Units app, right? So although we won't start coding with the class relations, as you develop, as you design, you should have some relations in mind. This is a fairly simple single activity app. So we definitely have the main activity. And then the question is, what does the main activity do? Again, this being a very simple app for now, at least, you can do everything in the activity, but it's recommended that you outsource the actual behavior of converting the temperature, etc., to a separate class. Okay? And that's what we are going to do. So our main activity will use a static, it will use statically a class named temperature converter, which has two static methods, Celsius to Fahrenheit and Fahrenheit to Celsius. Why statically? Well, we don't really need an instance of the temperature converter, right? We simply need to access these methods. We just need it as a utility class, only for the behavior as a helper class. So that's what I'm kind of modeling here. And then, since we are talking about TDD, I have drawn this temperature converter tests also in the picture, which will be testing all the methods that we want to implement here. Okay. So yeah, while I'm designing, these are a few things that I think about. Static methods, as we said, the UML notation is underlined. The plus here indicates it's a public method, and so on. You need the test methods to be accessible to this class. So it should be a public method. And yeah, I've also thought about the signature of these methods. Each of those methods takes a single value, for example, Celsius here, and returns a Fahrenheit equivalent, and both the parameter and the return value are real numbers, that is double in my case. Okay. So these are a few things that I will think about, although I have not put them down in code yet, because we want to start here. Okay, so this is where we'll start. So let me switch to the Android Studio. Remember last time we looked into these classes and saw how they run. Now what we'll do is we'll leave them as it is. You can also modify them because they are not really meaningful, but I'll actually go and create a new class here. So shortcut is Command N or Control N based on your OS. You can go to the package and do that, or you can also go to new, file, new, and then Java class. Okay, both work the same way. Do that, it pops up a window like this and asks you which class it is. So we'll use name temperature converter tests. Okay, so note that we are in the test part of it, not the Android test. Okay, and yeah, there we created. Okay, all right, and we can simply start writing our first test. What should the test look like? So let's say our first test case, we want to test the Fahrenheit to Celsius method and convert it for a special value. I hope you all know that 32 Fahrenheit is the freezing point, that is 0 degrees Celsius. Okay, so let's write a test case for that particular pair of values. Now, while writing test cases, it's very useful to think of them in terms of these given, when, then sequences. So, when is where you will call the method that is under test, and anything before that should be the given part. So given that the input is 32, when the Fahrenheit to Celsius method is called, then the output is 0. Okay. So if you think about test cases in these terms, like given, when, then, it's very easy to create and maintain test cases. All right, we'll go back to the Android Studio and start writing our test. So yeah, it should be public void, and the name of the method should be descriptive. It's recommended that you include the test, the method under test or the unit under test, its name in the test method. So, you know, when you see the report, it makes sense. So let's write Fahrenheit. I hope I'm messing up the spelling to Celsius. 32F is 0C. Okay. Yeah. And then I'll write given and say double input equals 32 when temperature converter from this dot heat Celsius is called on the input, and I'll capture the result in an output, and then remember the Hamcrest assertions. So we'll say assert that output is 0. Okay. Like this. Obviously, there will be compilation errors. Some of these we can fix because they are the import errors, right? So that's what we'll do. Yeah, this is the one we want. Okay. Is import the static method like we did last time. So this is our matchers is okay. All good. Okay. We still have a compilation error, and this cannot be fixed with imports. Okay, but I mean we are doing a very strict test-driven development thingy here. So we are writing the test cases before writing the code, and writing a failing test case, in fact, and not compiling is failing. So this is failing, right? How do you fix it? Again, do the Alt Enter, and it will tell you that it can create a class temperature converter for you. Where do you want to create it? You want to create it in Java units, not in test blah, blah, blah. It should be in main Java unit, okay? So make sure you choose the right path here and click OK. So you see the class is created here, but it's an empty class. So go back here. You still have the compilation error because this method does not exist. So let's go ahead and do it, right? And yeah, this is what you get. Public static double Fahrenheit to Celsius takes double input. And now this is showing a compilation error because it's expected to return a double and it returns nothing. So what is the easiest double to return? Well, 0, okay? So that's what we did. We wrote a failing test case and then wrote a code to, well, first of all, make it compile, right? Let's see, does it compile? Yeah, it compiles. There are no red squiggly lines anymore. But will it run? Think about it. Will it run, do you think? I mean, will the test case pass? The answer is yes, it will pass, right? So let's run it. Okay, starting time. Warming up, I guess. Yeah, and then it says it passed, right? Obviously it passed because we are looking for 0 and it's returning a 0 explicitly. Now, if you remember the test-driven development principles, the next thing you should do is write another failing test case. Okay, so think of some other value, again in the given, when, then format, right? So I'm going to write another test, public void Fahrenheit to Celsius. So let's take the boiling point of water now. 212F is 100C. And again, a similar given, and then structure input when input is 212, when this method is called. Now it's easy because it knows what it is. Then assert that output is 100. What do you think? Will this test case run? Obviously it won't, because it's going to return a 0. So let's just do that. Yeah, there it is. It gives you the report. And see, I mean, the advantage here, because we named it so explicitly, is you know which one is failing. Fahrenheit to Celsius for 212, 200C is failing, right? And like, that's what we want. Okay, so now we have a failing test case, and you should go back and fix it. Now this return 0 won't work. You also can't just change it to 100, sorry, 100, right? Because then this one will run. What happened? Oh, sorry, yeah, I totally forgot that. You should, and it does a type thing. Since we are dealing with doubles, you should make sure it's a double. So now this will run. Yeah. By the way, note how declarative this assert is. It just says assert that output is 100. And that's exactly what we want, right? Okay, so this will run, but the previous one will fail. So let me just run all of them. We'll see one running and one failing test case, right? Some of you may be thinking, why are we wasting so much time in it? You know the formula, just go and type it. And yes, agreed, but I'm trying to demonstrate test-driven development paradigm here, okay? So that's why we are taking baby steps here. So yeah, clearly this doesn't help. And what you should do here is convert it to like implement the formula, right? In fact, let me change this to Fahrenheit just for readability. And what I want to return is Fahrenheit minus 32 over 1.8, right? So you may be thinking times 5 over 9, that's the same thing. So yeah, this is the formula. This should work, right? Okay. Now let's see. Let's run both test cases. And both test cases pass, as you know. I mean, we have implemented the formula, right? So that's the idea here. So now our TDD part is done. Now for sanity check and other things like that, you can check for other values. Let's say, yeah, negative 40 is an interesting value because negative 40 is negative 40, right? It is minus 40, and output should also be minus 40. Okay, things like that. So all 3 test cases pass, right? So this way, I mean, you can add a few more test cases now and basically build your test suite. You can have a bunch of test cases that later, anytime if you make any change, let's say you make it times 5, sorry, 9 over 5, or 5 over 9, because we are doing times, right? Yeah, I hope that's correct. And I hope this should work. Yeah. So, right, I mean, any change you make here should be quickly tested here. So like the mistake I was making, if I was, this is a this is a logical mistake. So instead of 5 or 9, I'm doing 9/5. And you make that change, that's sort of a small change for whatever reason, and then run the test cases, and then they fail, right? So this is the advantage of doing automated testing. You will have your test cases always ready to go to test against any changes you make. Okay. All right. So we'll stop this video here. A quick recap: what we have done is we have used the test-driven development paradigm to develop this particular method of this class, right? I won't show how to work on the other method, the Celsius to Fahrenheit method, in a video, but obviously, you can do it in a similar fashion. So by the time you are done with it, you'll have a bunch of methods here in your temperature converter tests class. All right. So that's a demonstration of developing this utility class using TDD. In the next video, what we'll do is we'll start developing the activity itself. Okay. All right. Thank you, guys. See you soon. Bye.